Have you ever wondered how our solar system came into existence? Well, it's nothing short of a cosmic drama. Around 4.5 billion years ago, a colossal cloud of gas and dust in the Milky Way started to collapse under its own gravity. As this cloud collapsed, it began to spin and form a flattened disk with a hot, dense center. Now, imagine the heat and pressure at the heart of this collapsing cloud. It was so intense that hydrogen atoms began to fuse together, creating helium and releasing vast amounts of energy. This process, known as nuclear fusion, marked the birth of our sun. Composed mainly of hydrogen and helium, the sun accounts for a whopping 99.8% of the entire mass of our solar system. Its immense gravity holds everything together, from the inner rocky planets to the distant icy bodies. So that's how our sun, the heart of our solar system, was born, setting the stage for the formation of the planets. As we move away from the sun, we encounter the first set of planets, the inner or terrestrial planets. First up is Mercury, the smallest of them all. Its surface, scarred by countless impacts, resembles our moon. Next, Venus, shrouded in thick clouds of sulfuric acid, is similar in size and structure to our Earth, but incredibly hostile. Speaking of Earth, our home planet is unique for its liquid water and abundance of life, making it the jewel of the solar system. Then there's Mars, the red planet. Half the size of Earth, it's a cold desert world with the tallest volcano and the deepest canyon in our solar system. Each of these planets, though made of rock like Earth, is vastly different from one another. Venus is hot and toxic, Mars is cold and barren, and Mercury is a world of extremes. These rocky worlds, each with its own unique characteristics, are the closest neighbors to our sun. Venturing further into the solar system, we find the outer planets, also known as the gas giants and ice giants. These titans of our cosmic neighborhood are far different from the rocky worlds we call home. First up, we have Jupiter, the largest planet in our solar system. This gas giant is known for its distinct feature, the Great Red Spot, which is actually a storm that has been raging on Jupiter for at least 300 years. Imagine a hurricane that never ends. Then, we move on to Saturn, the jewel of our solar system. It's not hard to recognize Saturn with its spectacular rings made of ice and rock. These rings span up to 280,000 kilometers, which is about 3/4 the distance between Earth and our moon. Next, we have Uranus and Neptune, the ice giants. Uranus, with its peculiar tilt, spins on its side, making its seasons drastically different from other planets. And Neptune, the furthest planet from the sun, has the strongest winds in the solar system, reaching speeds of 2,000 kilometers per hour. You might wonder if life could exist in these extreme conditions. While we don't have definitive answers yet, the possibility always intrigues us. These distant planets, with their extreme conditions and spectacular features, continue to fascinate scientists and stargazers alike. Beyond the realm of the 8 planets, our solar system still has much more to offer. Let's start with the dwarf planets, the most famous of which is Pluto. Once considered the 9th planet, Pluto was reclassified as a dwarf planet in 2006. Despite its small size, with a temperature of -375 to -400 degrees Fahrenheit, a very low atmospheric pressure, and being approximately 3.67 billion miles away from Earth, Pluto boasts 5 moons and a heart-shaped glacier that's the size of an Oklahoma combined. Now, let's travel farther to the Kuiper Belt, a massive donut-shaped region beyond Neptune. With temperatures reaching close to absolute zero, a negligible pressure, and located between 2.5 and 4.5 billion miles from Earth, it's home to countless icy bodies, including many dwarf planets. The Kuiper Belt is like the solar system's frozen attic, a place where ancient objects have been offering us a glimpse into the early solar system. Finally, we reach the Oort cloud, a theoretical sphere of icy objects believed to exist at the furthest reaches of our solar system. With an estimated temperature below -370 degrees Fahrenheit, virtually no pressure, and located as far as 1.6 light-years from Earth, the Oort cloud is thought to be the birthplace of many long-period comets. It's so distant that it's more a part of the interstellar space than our solar system. These regions challenge our understanding of where our solar system ends. They remind us that the universe is full of surprises, and our solar system, as familiar as it may seem, has its share of secrets. From dwarf planets to distant comets, the outer reaches of our solar system hold many mysteries yet to be discovered.